Hey there, Math 124 fans. Going to do a quick discussion of one way I think is something good to do towards the beginning of your studying for any exam, especially in a course where they provide an extensive exam archive for you, which we do for our courses. That really gives you a fairly direct and somewhat easy way to start your studying and figure out where your holes are, figure out what you need to do, and it doesn't take much time. You could even do it like before or after you're sitting in your class. And that's to pull up the exam archive, pull up your like final exam review. I just grabbed something from my final exam review last time I taught Math 124. So we have these topics. So you'd have in your head a rough idea of topics, hopefully already. Exam 1 material, limits, secants, tangents, the beginnings of derivatives. And then we have the rest of derivatives, a bunch of stuff. Usually students have just studied that because they were studying that for exam 2, so that's often more fresh in students' heads. And then you have this new piece, which is really about analysis. And usually the final exam is heavy on this because it's how do you analyze a function with derivatives, which is the main thing we're trying to take out of this course. So a way to prepare your studying is get something like that ready, get a notebook out and say, I'm going to sit down and do a 10-minute little brainstorming session of the things I need to study. And so I've got my head in the middle here, looking back and forth, but I have the exam archive open, and I'm just going to pick, I'm going to go further back because I may go into some of these in more detail, but I just thought I would do this because this is a fairly efficient time thing. So I'm going to open the Winter 2018 exam. We're going to scan through it, make notes of what the questions are. We're not actually going to work through it. Then we're going to do the same thing for the other two. And we can do this in less than 15 minutes. And at the end of it, we'll have a really good sense of what we need to study. So I'm always surprised when students come to me and they're like, what does the final look like? What is the structure? And I'm like, well, you really should have already done this type of study if you haven't already. Okay, so here we have the Winter 2018 exams. You go, okay, I see what the cover sheet looks like. And then what I would be asking myself is, what's the very first thing I will do when I see that? And I have to put myself in the exam. Imagine I'm taking the exam, I open it up, I see this problem, and what am I going to do? Am I going to freak out? Or am I just going to start working? So the question says, do a derivative. To me, it jumps out at me what to do. So you should be thinking, all right, it's kind of a mess. All three of those are kind of a mess. So product, quotient, or chain. That's what I would be thinking. And that's a quotient rule. So I see we have these kind of right away, a problem where we're doing this stuff. So quotient. And that might have been on exam 1. Would I know how to do that? Do I know how to execute the quotient rule? And if I don't, you could have, this takes a little longer, and goes against the idea that I'm just trying to get a sense of what's on there. But you could pull up, this is my view page. You could pull up something where I do derivatives. That's actually not it. Or my lecture notes. And you can see examples where I do product, quotient, and chain. There's the quotient rule. And you would say, okay, I need to get that on my note sheet. But hopefully you know that. And you would need to also know the derivative tangent. Again, I'm trying not to spend a bunch of time on each problem because I'm just trying to get a sense. Okay, so let's kind of make a note. Winter 18. It looks like the next one is the chain rule. So Winter 2018 question A and B. I'm going to have to do product, quotient, or chain. And I can see on page 1 I'm doing derivatives. All right, so then I get to the third part of that question. Oh, there's an x in the base and an x in the exponent. That should jump out at you as a particular thing. If it doesn't, you need to add that to your studying. But there's a very standard thing we're going to do here. So as a student, I'd be like, okay, that's something I know. I know that that's that logarithmic differentiation. I know I'm going to take the log and then simplify and differentiate both sides. If you don't see immediately how to start a problem, that should be like an alarm bell. Because everything you're going to see on the test you've seen in some way. There might be, the issue is if you're regularly thinking, I don't know how to start, I don't know how to start, I don't know how to start. And then you got to slowly check those things off and go ask in the lab, go ask in your quiz section, ask in the Math Study Center. But you can see how it's probably not as many things, but this will give you a sense of where you need those interventions. And we can't really do that for you. Okay, so the next problem is a limit. Not surprising. So now we're starting to get a sense, at least this first exam, the first page was kind of direct derivative skills. And now I'm starting to see limits. So we'll put up here winter 2018. Question 2 is limits. And we're just trying to get, at the end of this, we'll have a really good picture of things. So do I know how to approach that limit? Yeah, I should plug in a 2. If it's 0 over 0, then I need more of an analysis. But I already have a plan. This one, what am I going to do? Well, that might be one of my special limits. That's what I'm thinking. The inside is going to 0, but this is going to infinity. So it's infinity times 0. So more analysis is needed. I think you do this in the L'Hopital's rules section. So this is actually from here. So that should be somewhat familiar by the time you get to that. Here we have one that looks like a mess, but there's this very standard strategy when you have infinite limits. If you don't remember that strategy, I have that here. So I curated a lot of materials over 20 years of teaching these courses. And you say, oh yeah, this is the one where we multiply by 1 over x to the a. That should be a set strategy. So I'd multiply everything by 1 over x to the 4th. You say, oh, I don't remember that. Add that to your study and try to find some more like that in old exams. Okay, so let's grab another one. Keep going. Because we're trying not to dwell on something that scares us and trying to just get a sense of where are our holes when we're doing this sort of studying. So in this problem, you use this expansion. I don't know what that's about. I've never seen this exam before in my life. I'm trying to experience it like you would. But they give me this function, the square root of x cubed plus 17. Oh, definition of the derivative. So I'm going to do the f of x plus h minus f of x stuff. I got it. That's great. So this is this definition of the derivative. Winter 18, 3. And I might have to remind myself, how did that go again? Oh, yeah, it was. And we're talking specifically about 2. All right, it's asking me to plug all this stuff in and simplify. All right. Do I know what the next step? If I don't, then that raises an alarm. You could put a little star next to it, ask about it in the Math Study Center. Maybe your first go through of this, you have a lot of things you need to go, but you will just chunk away. This is the proactive way to be successful. Okay, what's this one? This one jumps out at me. It's implicit. You can see it right away. We're going to do something to do with implicit. We're going to find the derivative. So it's an implicit derivative question. So that's winter 2018 question 4, an implicit derivative question. And you should know immediately how to do the implicit differentiation. So to me, this sort of studying, again, I keep saying it, but is something I find not very many people do. And to me, it's a natural place to start. Below is the graph of the derivative. Okay, a functional question. Now you had some of that on exam 1 and maybe exam 2. This terminology. This is going to be a collection of things. I do see the words increasing, concave up, critical numbers. So it is mostly about analysis and terminology. So I might say, well, I don't really have this here. Maybe I'll say winter 18, question 5 is a graph with terminology. And then I kind of chunk that away to look for it some more and come back. Okay, let's keep going. Graphing question. This is something that's on all the old exams. Curve sketching. This is something you can prepare for. And I find this is one of these topics that a lot of students miss, but it's something you really can prepare for. So and I'm kind of in doing so making notes to myself of short videos I might make later where I just go through and do a bunch of those. There's more. Question 7. You're designing a circular container. The volume of the top is this. What are the dimensions of the cheap? This is a minimum question, optimization question. That's the applied max and min. So this is winter 18. Number 7. Oh, and then what do we have? I kind of know because if you've prepared, you know what it is. You could say, what's my first hunch? And then read it. But my first hunch is this is related rates. A dog is running around a circular track. His owner is standing here. How fast is the angle changing? Oh, it is related rates. So related rates. Maybe we're not surprised that that's on the test somewhere. And not only should I know what's related rates, I kind of have a plan. I'm going to label everything. I'm going to write down what I was given. I was going to write down what I want. I like these questions simply because for me as a student, I have a plan. I have a clear plan of attack. Might get stuck somewhere in there, but I'm not going to worry about that yet. Okay, so there's one tour, and we've already gotten a good sense of, all right, it looks like we're going to be asked these things, so I'll definitely prepare here. I'm certain I'm going to have to do a limit. I'm kind of just making observations on what we had. A lot of derivative stuff. There was a definition of derivative, product, quotient, and chain. There was an implicit, and there was a related rates. Let's now run another experiment. Okay, so we're going to do spring 2018. Click. You can see this doesn't take that long. There shouldn't be stress at this point. You're just thinking, okay, page 1 is derivatives, quotient rule. In fact, it's the exact same thing in terms of format of what the last one was. Ooh, we got kind of a mess. There's going to be some sort of logarithmic differentiation. There's going to be a chain rule. So it's a different ordering, but I go, it's the same ideas. Okay, let's keep going. Let me know if this is give me a like or give me a comment if this is a valuable thing for you. Because I'm finding more and more people don't do this. Because when I go through and look at a test and I'm like, I just wrote a test and the question's very similar to the exam archive, and then students don't know how to start it. That's the thing. I think people aren't doing this form of studying. Okay, so then we have limits. Okay, we're starting to see kind of somewhat formulaic here. That doesn't mean that exam's going to look exactly like that, but it gives me a sense. Do I know how to do a finite limit? I evaluate and then do some algebra. Do I know how to do this limit? Do I know that I need to bring things together? Do I know how to do this limit? I think that's a special limit. So there's more than one way. Question 3, what is that? That's implicit. That should jump out at you. It's implicit. There's a tangent line approximation, but really the key point is doing the implicit differentiation. So that's another example of this. Spring 18. And I think already, if I was a student, I'd be like, okay, I'm getting a sense of the big themes. Students tend to focus on the most obscure questions they find in the archive and ignore the big themes. A highway patrol plane flies 0.8 miles above a straight road at a steady ground speed of 120 miles per hour. The pilot sees an oncoming car with radar, determines that the line of sight distance is this. Calculate this car's speed along the highway. Now that sounds a lot like related rates to me. So we have a spring 18. If you don't know how to categorize something, you could just throw it in the corner and put a little question mark next to it and come back to it later. But don't dwell on it for hours and hours. I think that's where people go wrong. This one I immediately see as some sort of minimum. Okay, you want to manufacture this, you want a minimum, that's an optimization question. Do you know your first steps? That you're going to label everything, figure out what you're given and what you want. We have a graph sketching. So here we have another curve sketching, spring 18. That's the fundamental idea you're doing in the last couple weeks. You're going to find the derivatives, you're going to do the critical numbers, you're going to do the analysis, and I'll do a video on that at some point. Happy to, but that's a major theme. Number 7 looks like some sort of continuity differentiability question. You're going to plug in 1 to both sides and just see what's happening for both sides. This is one of those questions that I find scares students, but I really like. I feel like it's somewhat straightforward in terms of how you're going to approach, but I can discuss that if someone wants. Okay, so there I saw a few things. There might have been a couple things different that bothered us, but did we understand the bulk of how to start most questions? That's what we're trying for when we're doing this sort of studying. So one more, autumn 2018. Looks like a chain rule. The fact we need to get to a point where if it's a messy function, we're not scared. Derivatives are just sequential. You're going to do the derivative of the outside, then see where you're at. Then do that derivative and see where you're at. So you should never be scared of a complicated bunch of things because you're just going to do it in pieces. Anyways, the very first step of the first one is you're going to take the derivative of the log. And then you'll do that, and then you'll work from there. The second one, you're going to start doing the product rule. Then you'll deal with the smaller pieces of that. Third one, you're going to do logarithmic. Boy, these were very formulaic. This is a couple years ago, but I see a lot of commonality between those 3 exams in terms of what we saw there. Let's keep going. Limits. Infinite limit, we have a certain strategy. Again, if you needed a review, you could go over here. I have limit practice. But you don't know what to review until you've done what we're doing now. So another limit, winter, fall 18, question 2. Okay, what's this about? At what rate? It's a related rates. You can see how I just went straight to the end. And in doing that, I'm getting better at identifying things like this. Okay, what's this about? How far north does the dog run in order to minimize his time? It's an optimization question. So you can do the same. In doing this, you're going to build confidence that you're going to know what questions are about. You're not going to be guessing. What's this one? Implicit. So we have an implicit question. How did I see that? Because I have multiple variables here. Fall 18, question 5. All right. Parametric. We haven't seen that yet. So this is why it's good to look at a few. You don't want to assume that glancing at a couple of exams covers everything. So fall 18, we have a parametric. Number 6. All right. Would I know how to do that? Would I know how to start? We have a curve sketching. That's this fall 18, number 7. All right. We should know how to do that stuff. Done. So I'm going to stop the video there, but the point was you now see things you definitely would want to study are applied max and min, curve sketching, related rates, implicit, derivatives, and limits. Now, I'm not saying that's your test, but you can inform yourself in this way. You should know a little bit of everything. I mean, you've been doing the homework all term, but you can see things right away that you're like, if I don't know that, I know I'm in trouble. I better go and review that. All right, I hope you found that helpful. Let me know if it was, or if you'd like me to do particularly one of those topics, let me know in the comments of the video.